Alright, let's look at the homework 16.1, problem number 10. Alright, so let's look at part A. Alright, so we want to sketch the vector field I plus 7xj. Alright, so let's do that. Alright, so here's the x-axis, and here's the y-axis. Alright, so let's start with the origin. Maybe I'll mark this. It's a 1, 2 here. It's a -1 here. X equals -2. And here is x equals 1 and y equals 2. Here's y equals -1 and y equals -2. Alright, let's start with the origin. Alright, origin is 0, 0, but the x component is 1, so it's going to be facing this way. Alright, at 1, 0, 1 and this is 7, so you're going to have a vector pointing up. And here 2, you put the 1, 14. I can't quite do it in the right scale, but it's going to be much steeper. Alright, if you look at the -1, 0, it's going to be 1, -7, so it's going to pointing down this way. And -2, 0, so 1, then it's going to be -14, so it's going to be pointing down that way. Alright, so if you go up one notch, it's actually exactly the same because it does not depend on the y value. So it's going to point this way, and point that way, and point that way, and here point that way, and point that way. Right? Same thing here, and up, and steeper, and down, and steeper. And if you go down here, it's the same way. Go here, and up here, and steeper there, and down here and steeper there. Right? So you can see that the flow of this vector field, if you follow this, it's going to look probably something like this. So you follow this and you get flat here and then get steeper and steeper. Right? So it looks like this is going to be a parabola. So you have a parabola here. Right? Let's check the answer. Alright, so we put parabola and submit for testing. Alright, it came back and looks like we got this one correctly. Alright, so let's do part B. If a parametric equation x equals x of t and y equals y of t, what differential equation do these functions satisfy? Right? So we want to come up with the dy over dx, right? But the dy over dx can be broken down into dy over dt divided by dx over dt, right? But the dy over dt is the derivative of y component with respect to time, which shows up as the y component. So this is going to be 7x. And then divided by dx over dt shows up as the x component, which is 1. So this is going to be equal to just the 7x, right? So we have, hence, dy over dx is equal to 7x, right? So you have dy over dx equal to 7x. Alright, so let's look at part C. So we're going to have to solve that differential equation. So let's do that. Alright, so you have a dy over dx is equal to 7x. All you have to do is find the antiderivative. So with respect to x, antiderivative of dy over dx is going to be just y. Antiderivative of 7x is 7 over 2 x squared plus some constant c, right? But it says that it go through the origin, so it has to go through 0, 0. So we can plug in y of 0 is equal to, that's 0. You just get c. This has to be, y has to be 0 too, so c is equal to 0. So therefore, the equation is y equals 7/2 x squared. Right? So let's type it in. we got the y equals 7 over 2 x squared. All right, let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.